This podcast will help you get ready for the Tis the Season investigation, and it's going to focus on the Earth in space. To start off with, we need to make sure we remember all our vocab words. Axis is the imaginary line through the center of the Earth, which we can see in this picture here. The axis is at a 23.5 degree angle to the perpendicular. Next one is taking a look at rotation. Rotation is the spinning of an object on its axis. It's very important to make sure we understand both rotation and then its other word, revolution. Revolution is the movement of an object around another object. When we take a look at it, remember rotation takes 1 day on Earth, whereas a revolution takes 1 year on Earth. So take a look then at what causes the actual seasons, what's actually happening here. Remember, a season is just a temperature difference from place to place. For example, right now we are experiencing winter in Indiana, whereas down in the southern hemisphere they're experiencing summer. And this all has to do with being further from the equator, we have more weather changes. This is especially evident when you consider that in Fort Wayne here, we've had temperatures as low as in the negative teens, all the way up to 110 degrees within the last year. And that has to do with being a fair distance away from the equator. But the actual driving force then for what's causing these changes is the tilt of the Earth's axis combined with how the sunlight actually hits the Earth's surface. So let's take a look here at the tilt of the Earth's axis. The Earth is tilted at a 23.5 degree angle that is perpendicular to the ecliptic. Basically, you consider a big table that the Earth is going to revolve on. It is tilted 23.5 degrees from a line that goes up perpendicular to that. You can actually see the right angle indication there. Now, making that angle can be difficult until you consider that a pencil in a solo cup is at a 23.5 degree angle approximately. And that works out pretty conveniently because that's what we need for our experiment. So you can see here I've taken the styrofoam ball that is on the pencil and placed it into the plastic cup. But even more importantly, I also put a piece of clay at the bottom of that plastic cup to keep it weighted down so that it didn't go flying across the room or keep tipping over on me. This creates an almost perfect 23.5 degree angle, so you spend more time looking at the actual investigation of what's going on and how the shadows are changing, and less time just trying to get the Earth in the right place. Now, when we look at the tilted axis then, we can see it has a huge effect then on the seasons, especially on the fact that we can see that the sun is or the northern hemisphere in June is pointed towards the sun, which means that it is experiencing the summer season at that point. Whereas we can see in the month of December, the northern hemisphere is tilted away from the sun, and so that means that it is experiencing winter at that point. And then in March and September, we are having the equinoxes and getting a roughly equal amount across the surface. Now, the more important part then to look at that is how the sunlight's actually hitting the Earth and how that is affecting the seasons. Now, the tilt drives the fact that the sunlight hits differently, but if we look at it, near the equator, the sunlight is actually not spreading very far. You can imagine almost as a very direct hairdryer blowing at the center of the Earth, because the sun is providing lots of energy in both the form of heat and light. But near the poles, that same amount of light is actually getting spread out across a larger area. So you can imagine actually taking the hairdryer and holding it at an angle instead. You don't get as much heat concentrated in a small area, and so therefore it actually causes the temperature to change a little bit. It can become a little bit cooler. But if we look at it then during the winter months of the northern hemisphere, which this picture shows, you can see the sunlight spread over a much larger area than it is in the southern hemisphere right now. It's getting a little bit more of a direct sunlight. And that makes sense then when you start to consider the changes. Now again, if you have questions about any of this, you can pop onto My Big Campus and ask them on there. You also can ask during class. Remember, you need to have your procedures taken care of before you get into the lab. So make sure that you go through and write all the details out, especially how you're going to set up the cup to get the 23.5 degree angle, and then how you're actually going to demonstrate how the sunlight hits the surface of the Earth.